Alright guys, I welcome you to today's class. In the last class, we'll handle the process synthesis and the analysis of the process, how to create the chemical processes, and also how to describe a chemical process. So we talked about the flowsheet descriptions, but basically we have two types of process description. We have the qualitative description, we also have the flowsheet description. So under the flowsheet description, we took time to talk about the different flowsheet description, talked about the block diagram, the flow diagram, the information flow diagram, and the quantitative flow sheet description. So under the quantitative flow sheet description, we'll say that they exist in different forms. That what we said. We'll say they will have the process matrix, the incident matrix, the stream connection matrix, and the adjacency matrix. So in the last class, we'll solve some examples and we'll saw the applications on how we can actually convert the information flow diagram to a process matrix, or rather to a quantitative flow sheet description. So in this very video, we will solve further examples, but this time around you have more equipment numbers. In the last, thank you. It's a process matrix, so we want to actually convert it to a stream connection matrix. So you have the equipment number, the equipment name, and the associated streams. So using the table, we are to generate the information flow diagram, we are to generate the stream connection, the incident matrix, and the feed streams. So actually what I do, basically an easier way to do this is to first of all get the stream connection matrix. So that is one thing I like doing. I have to get the stream connection matrix first before I will now start solving, or before I start drawing the information flow diagram, and through that I can now get other ones. So let's start with the stream connection matrix. Remember the question already, they've given you the process matrix, so from there you can now generate every other thing, and that's how the question comes. You have about 14 equipment and up to 14 streams, or more than that, about 18 streams or thereabout. So let's see how we can actually convert the process matrix to a stream connection matrix. Okay, we have the process matrix, so we can actually refer, because we need it to actually get the stream connection matrix. So the way I do this is just to look at the streams. So but remember the format, so let's look at the format. That's the table. You have the stream number, you have the source unit, you also have the destination. So how I do my own is just to look at the stream numbers. The positive stream numbers will tell me the destination unit, while the negative stream numbers will tell me the source unit. For instance, if a stream number is 1, what does it imply? Plus 1. It tells me that it is coming from somewhere. It tells me the destination of that very stream. So positive for destination, negative for source. So for the first stream number, I have stream number 1. So that tells me that the destination unit of stream number 1 is the mixer, which is M1. But it has no source. If you check all through, you will see that we don't have any negative 1. Hence the source is what? 0. Even in the last lecture we talked about this. For feed without a source, we'll give it what? The number 0. For a product without a destination, we also give it a 0 as well. So that's what we have here, M1. So let's check out stream number 2. So for stream number 2, we have a positive value here, which tells me that the destination is M2. When I check, do we have a negative 2? All through, we don't have a negative 2. Hence, the source is 0 and the destination is M2, that's the mixer. Stream number 3, you have the negative minus 3 coming from M1, so that's the source unit mixer. The destination is pump, that's P1, because you have 3. For stream number 4, you have negative 4. So, and that source unit is the pump, which is also P1. You have positive 4, and that is for equipment mixer, that's M3, mixer 3. So we'll have our M3. You have stream number 5, it has a negative value. The negative, that means the source at M2, that's a mixer. You have the destination, positive 5, pump. Negative 6. Negative 6, do you have negative 6? Yeah, negative 6 is P2. And then positive 6 is M3. Hope you are following. You have a negative 7 is M3. Positive 7 is E1, that's the heat exchanger. Positive, negative minus 7A, that's 7A, negative 7A, that's the heat exchanger. Positive 7A is the furnace. Negative 7B minus 7B is at the furnace. Positive 7B is compressor C1. So that's how we do this. So let's compute for others. Okay. For 7C, positive 7C is E2 heat exchanger, negative 7C is compressor C1. That means the source is C1, the destination is E2. Okay, so the reactor now, let's check unit number, that's stream number 8. Positive 8, or let's say from negative 8 is E2, that's the source is E2. Positive 8 is a reactor, that's R. Negative 9 is the reactor as well, R. Then positive 9, let's check. Positive 9 is the heat exchanger, E1. Negative 9A is the heat exchanger, E1. Positive 9A is the heat exchanger, E3. Negative 9B, you have heat exchanger, E3. And positive, you have the valve. Number 10, that's the stream number 10. You have the minus 10 to be for the valve, V. Positive 10 is for the vessel, V2. You have the stream number 11. The negative is a flash vessel, V2. Then the destination, positive, that's 11 for M2. So you have stream number 12. The negative is the flash vessel, V2. The positive 12 is distillation column, C2. You have 13, so this is a mistake. This should be minus 13, okay? So that means distillation, C2, and then plus 13, the mixer, M1. Okay, so we have the last stream number, which is stream number 14. The destination is minus 14, which is C2. The other one, it has no source. The destination, check the destination, we don't have positive 14, hence we assign 0 to it. So this is your stream connection matrix, which was obtained from the process matrix as fast as possible. So that's the hint, okay? Right, let's now see how we can obtain the information flow diagram. Okay, so first of all, you just scatter the equipment based on the process matrix. So from the process matrix, we will actually scatter everything, just the series or the sequence in which the equipment follows. That's the same thing you are to do. You have equipment 1 down to equipment 14, so just follow the same sequence. Okay, follow the same sequence for that very equipment and then list out your equipments. So let's see, this is the order in which they gave the equipment in the process matrix, and that's the same thing I'm doing right away. You have the mixer, you have the pump, you have the mixer as well, you have another pump, P2, the mixer, M3, the heat exchanger, the furnace, the heat exchanger, the reactor, the heat exchanger, the compressor C1, the flash vessel, the valve, and then the distillation column. So that's the order in which they gave us the equipment in the process matrix. So first of all, scatter each of those ones following the sequence that they gave you in the process matrix. Now you now refer to your stream connection matrix. So that's one thing you ought to do at this point in time. Refer to the stream connection matrix. When you refer to the stream connection matrix, it becomes easier to actually get the information flow diagram. So this is the stream connection matrix. So destination, stream 1 now, you have the source unit 0, destination is M1. So stream 1 has no destination, but it has no source, but it has a destination, and the destination is what? M1. So that's what we have here. It has no source, but it has a destination. Stream 2, the same thing. It has no source, it has a destination, M2. So we attach our stream 2 to M2. You have the stream 3, it is connecting, the source unit is M1, it is going to P1. So from M1 to P1, that is stream number 3. Stream 4 is from P1 to M3. So from P1 to M3, P1 to M3, you have your stream 4. So stream number 5 is from M2 to P2. So you have from M2 to P2, stream number 5. You have stream number 6 from P2 to M3. So you have from P2 to M3. That's the stream number 6. Stream number 7 is from M3 to E1. So we are moving from M3 to E1. That's your stream number 7. Stream number 7A is from E1 to H1. That's your heat exchanger. So we are moving from E1 to H1. So the next one, that's your furnace. Not heat exchanger, the furnace, from a heat exchanger to the furnace. So you have your 7B from your furnace to your compressor C1. So you have from H1 to C1. That's your 7B. Stream number 7C is from C1 to E2. So we'll move from C1 to E2. Stream number 8 is from E2 to the reactor. So that's you have your stream number 8. Stream number 9 is from the reactor to the heat exchanger E1. So we'll move the stream from the reactor. We'll draw a line from the reactor to the heat exchanger E1. Stream number 9A is from E1 to E3. Hence, we also draw a line from E1 to E3. So we have it from E1 to E3. So the next one is from E3 to V, stream number 9A, from E3 to V. So we move from E3 to V. That's what we have. The next one is stream 10. We are moving from V to V2. So that's what we have here, stream 10, V to V2. Stream 11 is from V2 to M2. So we're moving from V2 to M2. All right. Stream number 12 is from V2 to C2. So we're moving from V2 to C2. Stream number 12. Stream number 13 from C2 to M1. So we're moving from C2 to M1. Okay. Then the last stream is from C2 to 0. That means we have no destination. So we're moving from C2, we have no destination. So this is the information flow diagram. So let's go over to the incident matrix. Now I'd like to talk about this. For the incident matrix, it's easy to get it from the process matrix. Easy to get it from the process matrix. So that's what we'll see. Remember, from your stream connection matrix, you can get the information flow diagram. And from the process matrix, we got the stream connection matrix. So this is the our process matrix, and then these are the hints. Let's look at these hints again. Okay, so +1 for a particular stream number means it entered an equipment unit. A -1 means that it leaves a unit. If the sum of a particular column is equal 0, then the stream connects to equipment. If the sum is equal 1, then the stream is a feed. So all these hints will be applying in the stream in the incidence matrix. So let's see. Right, that's the incident matrix. Now if you check, you have to list all the streams. These are the stream numbers for incident matrix. Do well to visit the former video in which we treated an example on incident matrix, but now we have a complex incident matrix because we have up to 12 streams. The last one we treated in the last video was just 6 streams. So just list the streams from 1 to 12. You now have the equipment number from 1 to 14. So how do we actually convert these ones? It is very easy to do this. What you do, for all stream numbers that are positive, assign 1 to them. For all stream numbers that are negative, assign -1 to them. Remember, the tactics to do this is from the process matrix. You do that from the process matrix. So observe the process matrix. All stream numbers having positive, put 1 there. All those having negative, you put -1. So that's what we'll be doing now. Check the process matrix. So from the process matrix, that's what we did. Stream by unit by unit. For unit 1, we had only stream 1 and stream 3. So positive, stream 1 was positive, we'll give it 1. Stream 3 was negative, we'll give it -1. Okay. Now for unit 2, in unit 2, we had only stream 3 and stream 4 in that very unit. Check it. So we assign positive to stream 3 because it had a positive value. It was positive initially, and then this was negative. We have -1. So that's the same thing that we did for each of these units. Each of the units will assign +1 and -1 to them. Okay. Now you get the sum. The sum of this very one is 1. The sum of this one is 1. If you sum them, it gives you this. Now, if you are now asked to get the feed streams, the product stream, and the recycle streams, that one is quite easy. What you do is to check out the sum. The sums that are positive are the feed. If you check, stream 1 and stream 2 are the feed streams because their sum is 1 and 1. If you don't want to get it from the incident matrix, you can as well go to the stream connection matrix. Any stream having a destination without a source is a feed stream. So from there, you see that stream 1 and stream 2 in the very stream connection matrix are the only streams that have a destination but without a source. So from this incident, you can also obtain that as well. So this is 1 and 1. Also, you can check out for the product streams. Sorry, this very one is out, but basically you see that the sum for stream 14 is equal 1. The sum for stream 14 is equal 1 because stream 14 equal minus 1, sorry, because stream 14 is a product stream. You can also check your stream connection matrix. You will see that the stream that has a source without a destination is a product stream. So if you don't want to use the incident matrix to get this, you can as well use the stream connection matrix. So you will see that that is equal to what? 14. So that is minus 1. So stream 13 as well, you will check the value at a 0 as well. So that is all for now. So you get the recycle stream. When a plus 1 is above a minus 1, you know that that's a recycle. When a plus 1 is above minus 1, that is a recycle. So that's all for now. The next one, this is an example you ought to solve. So try solving this yourself. Try this out yourself. We have 15 equipments and about 26 streams. That's them big. But if just try and do that, in the next class we'll actually solve this, so you can actually see the right solution to it. Okay.